Okay, we're looking at the second year Stats and Mechanics textbook, and we're on exercise 6C, which is from the projectiles chapter. Okay, so we have got, let's get my iPad up. We've got an object projected from a fixed origin with a velocity 4i plus 5j. So that means it's going 4 to the right and 5 up. So, quick sketch of that. And particle moves freely under gravity, passes through point P with a position vector k times I minus j. Okay, so what's going to happen? So if it's moving under gravity, it's going to carry on going up for a little bit and then eventually come down. And if it's at the position vector k, so obviously we don't know k, that's what we're going to find. But if k is a positive, so at this point they're describing here, it's at ki minus kj. If we use the brackets, it doesn't really look like an I, does it? So k, not much better. Well, so ki minus kj. So and k is positive, so that's at a positive I coordinate. So that's somewhere to the right of the origin, but it's a negative j position. So that must mean that, so if that's my x-axis, it's come down below the x-axis. Okay, so this is not the ground, because it's not stopping when it hits that. It's going down because it's ending up at a negative j position vector. Okay, and we need to find the value of k, and that's the only information we're given. Okay, so let's have a think about this. So I'm going to need to think vertically and horizontally. So let's go horizontally first, because that's always easier, usually easier. Okay, so it's traveling to the right. So it's traveling right with initial velocity 4. Yeah, that's what the 4i is. It's traveling a distance, or its displacement. So let's just label that as, need brackets. So this is what was given to me in the question. So that's ki minus kj as a position. So it's traveling, its displacement in the horizontal direction is k. It's traveled k to the right, and t, I don't know. Okay, so if I use, and acceleration, we don't have to worry about air resistance or anything like that. So acceleration to the right is 0. So it's constant velocity. So I can just use displacement is velocity times time. So displacement is k in the horizontal direction. Velocity is constant 4. So k is 4t. Okay, so let's leave that for now, and we'll come back to that. Okay, so then what's going on vertically? Well, so vertically, and we're taking up as positive, u is 5. Its initial velocity upwards is 5. Acceleration is minus g, because obviously g is working downwards. Its displacement is minus k. So I don't need to worry about the fact that it went up first and then it came back down. If I'm looking at displacement, I'm just looking at its actual position at that point in time. So its displacement from where it started is minus k, and t, I'm calling t. So I'm going to use s equals ut plus a half a t squared. So s is minus k, u is 5, a is minus g, so that's going to become minus a half g t squared. Okay, and if you've worked through the previous questions, this is a harder one, but it's very much following the same structure as a lot of the earlier questions, in that I've got two equations. This time, and normally I want t at this point, but this time I want k, so I am going to eliminate t. So I'm going to rearrange this to say that t is k over 4, which I haven't done anything daft there, now I'm fine. Then I'm going to substitute that in here. So wherever it says t, I'm going to substitute in k over 4, so I'm just going to be really careful when I square. So I have got minus k is 5t, where t is k over 4, minus a half g, and t is k over 4, and that's all being squared. So it's looking a bit nasty now, but actually that is just going to be a quadratic in k. So let's lose those brackets. So minus k, so if I multiply the first set of brackets, I get that. And then the second set of brackets, so in the numerator, I'm going to have the g and k is being squared. I'm going to square that 4, that's inside the brackets. So that's going to become over 16. But then I've also got that half there. So overall, that will be over 32. So as I said, it looks a bit nasty, but actually it's just a quadratic in k. There's my k squared, there's my k, and there is no constant because that's also a term in k. So let's tidy it up. I don't have to do this, but I'm going to multiply through by 32. I think it will just make it look a little nicer. So if I multiply through by 32, that becomes minus 32k. 32, so divided by 4 is 8, so times by 5. That'll become 40k, and it will cancel that fraction there. Okay, that's not essential, just makes the whole thing look a little bit nicer. I'm going to bring the minus gk squared over to the left-hand side, and then also minus the 40k from the left-hand side. So that will be 72k. Okay, so again, remember it's just a quadratic in k, so I can take out a common factor of k. So that'll become gk minus 72. So either k is 0 or those brackets equal 0, which would mean that gk was 72 if I have the 72 over. So k is 72 over g. Okay, so k is 0. Yeah, that's we can discount the k is 0 because if k is 0, then the position doesn't exist. There is no vector there. So we're getting 72 over g. So let's just quickly check that before we move on. So let me just double check. 72 divided by 9.8 is 7.35. So we're good. Okay. So find the speed of the object at the instant when it passes through P. Okay, so now we know what K is as well. Okay, right, so. The position of P is 72 over G I minus J. So I'm just going back to what was given to me in the question and substituting my value for K. I've gone back to the exact value. They rounded this to 7.35. Either should be fine. And I want the speed when it passes through P. Okay, so the speed, to find the speed, we're going to want to find the velocity. I'll just go back to my diagram. Okay, so I want the velocity at this point, and then speed is just going to be the magnitude of the velocity. So let's have a think about, so that's point P. Okay, so let's have a think about what we know. Well, so I need horizontal and vertical. So let's start horizontal. That's easier. And horizontal is super easy, in fact, because its initial velocity to the right was 4, and there is no acceleration horizontally. So that's also its final velocity. So its velocity to the right is just a constant value of 4i. Vertically, not so much. So what do I know vertically? I know that the initial velocity was 5 upwards, that acceleration is minus g, because that's working downwards, is positive. I know that the position is minus 72 over g. Yeah, remember the position of the vertical displacement at that point was minus kj, so minus our value of k. And I want, so sorry, why have well, it is k, but I didn't really want to write k there, did I? I wanted to write s, so I can use my Suvat equations, and I want the velocity. So I was actually thinking I was going to have to find time, how long it took, but I don't, because I can just use v squared is u squared plus 2as. So v squared is 5 squared plus 2 times minus g times, so let's squeeze that in, comes minus 72 over g. Give myself a bit more room. So v squared is 25. I've got 2 negatives there, haven't I? Yep, so they are going to cancel. And then I've got 2 times 72. I was going to say I'll leave it in terms of g, but those g's are going to cancel, so that's not a problem. So that's just going to leave me with plus 144. So v squared with 169. So v is, well, plus or minus 13. And it's actually not going to make a difference to the speed. Sorry, I can't see. So it's not going to make a difference to the speed. But actually, if I go back, I feel sick. Right, if I go back to here, I can see at this point it is travelling. So it's travelling to the right and it's travelling down. So it will have a negative vertical velocity. Won't actually make a difference to our final speed. But if this was, a show that question or a proof of something, it might matter. So its velocity at that point as a vector is 4i, because that was just never changing, minus 13j. So its speed, and always read the question carefully, because this is a very easy mark to, well, it's an easy mark to earn and it's an easy mark to lose, because you could get a method mark here, even if your velocity wasn't totally correct, because otherwise you're clearly using Pythagoras to find speed. So I am getting that as root 185, which is 13.6. And actually, I don't think I did end up using g because my g's cancelled. So I think I'm okay to go to 3 significant figures for that answer. I think that does make sense. Let's just quickly check though before we move on. Yeah, 13.6, we're good. And the direction of motion of the object at the instant when it passes through P. Okay, so yeah, we're nearly there. So this was our answer to, was that part 1? Were they calling it? Yeah, so this was our answer to B part 1. So B part 2, basically the direction. Well, if there's anything to do with the direction it's traveling or anything like that, that's going to be to do with its velocity. So as we've said here, at the point it passes through P, it's travelling with a velocity of 4i, so that's 4 to the right, and 13 down, minus 13. So that's the direction it would be travelling in. So I think the best way to describe that is probably to find that angle there and give it as a direction below the x-axis. So let's call that alpha. So tan alpha is opposite over adjacent. So alpha is arctan of that. So arctan 13 divided by 4. So fingers crossed, I'm getting that as 72.9 degrees, and that's 72.9 degrees below the horizontal. Let's just check that. Fantastic.